Okay, so today we're going to work on some vector addition and subtraction, and visualization of vectors and finding components of vectors and all that good stuff. So let's say we have this problem here. Vector A has a magnitude of 40 millimeters and points in a direction 20 degrees below the positive x-axis. Vector B has a magnitude of 75 millimeters and points in a direction 50 degrees above the positive x-axis. The first thing I'm going to do is I'm going to visualize this. So ideally I'd be using a straight edge here, but I don't have one of those for the computer, so make this work. So here's positive y-axis, here's the positive x-axis. Let's say that vector A is this pretty blue color. Vector A has a magnitude of 40 millimeters and points 20 degrees below the positive x-axis. So this is the positive x-axis here. Below it obviously would be down. And I'm going to eyeball this again. If I were doing this, ideally I'd be using a protractor and I'd measure the angle, but I'm going to eyeball and I'm going to say this is about 20 degrees this way. And it's important to note that 20 degrees below the x-axis is the same as 340 degrees in standard position, because the entire thing would be 360. 360 minus 20 is 340. So if you're working with a program that doesn't allow negative angles, it's important to know how to convert it to the standard form one. That's just by subtracting it from 360. So 20 degrees below the x-axis is the same as 340 degrees, or it's the same spot. So that's that one, and it's got a magnitude of 40.0. That's that fella. Let's say that vector B is red. Red points in a direction 50 degrees above the positive x-axis again, so it's still on this right side. And it's 50 degrees. I'm going to eyeball that. There-ish. That might be more like 60, but there. And it's 75, so it's almost double the blue one. So I'm sure I made more room. That looks pretty okay. So this is 50. And this is 75. No. All right, so I've drawn my two vectors. Let's say that I want to add them. Or I'm told to add them. Not many people just by nature want to add vectors. I don't know. Let's say I have to do A plus B. And A plus B equals C. There we go. Equals C. So let's do some let's graphically add them first to get an idea of where C will end up, and then what we'll do is we'll find the components of each vector and go from there. But let's first just see what it would look like. So if I'm going to add A and B, graphically it's going to look like this. I'm basically going to take from the tip of B, I'm going to kind of draw out A again. It's at that same angle, and it's the same length. And then what I'm going to do from the tip of A is I'm going to draw out B again. Same angle, same length. Okay, good enough. And then C would start at the same point that the other two vectors started, and it would be the diagonal between the two. So this is what C would look like graphically, like that. But to figure out exactly what the magnitude of C is, or what angle C is, I mean, you can eyeball it here. You can get a good guess, but obviously guessing isn't going to be quite enough. So let's do it mathematically. And to do that, I'm going to find the components of A and B, and then I'm going to add them, and then I'm going to use that to find the components of C. I can use that to find the angle, and I can also use that to find the magnitude. So component of A, let's do components of A. So I need to find the x component and the, whoops, I wanted to make that smaller, and the y component. Okay, so A is this one here, and it's negative 20 degrees. I'm going to go with 340 degrees because I know that that's how my calculator will read it. And I have essentially the hypotenuse. If I want to find the x component, I'll be using cosine, and if I want to find the y component, I'll be using sine, and I'm going to do the hypotenuse, or the magnitude, times the cosine of my degrees. The same thing with sine. 20 degrees. I actually haven't tried negative. I'm sure the calculator does work fine as negative 20, but I'm not going to mess with it. So let's do the first one. So 40 cosine 340, and whatever calculator you use, make sure you're in degree mode. I'm in degree mode. I double checked. So we get an x component of 37 point, let's do 59. 59. And let's see what we get for the y component. 40. Now this one should be negative because we're below the x-axis. Let's see if I get this right. All right, there we go. It is negative. Negative 13.68. Okay, let's do the same thing for the components for b, vector b. For vector b, we're going to have to do 75 times the cosine of 50 degrees to find the x component. And we're going to have to do 75 times the sine of 50 degrees to find the y. So I'll clear that out. Now these should both be positive because I'm above the x-axis, and I already knew I was in the positive x direction, so they should both be positive. Let's see what we get. 75 cosine 50 degrees. 48.21. And my final answer, I'm going to just use 3 significant figures, but while I'm doing calculations, I'm going to keep an extra one. Some people keep all of them, all the decimal points, but I don't have time for that right now. Not a bad idea to do. It really won't change your answer too much in the long run, usually. Okay, so there's the x component. I'm sorry, the y component where I found the x. 57 point, did I type that in right? Yeah, 57.45. Okay, all right. So now we have the components of each. Because we are adding a and b, I'm going to add the 2 x's and I'm going to add the 2 y's to get the components for c. So the x component for c is going to be the combination of the x component for a and the x component for b. And same thing for the y's. I'm going to level with you. I really don't know if I'm using the terminology properly. I've never actually heard it out loud. Oops. I just distracted myself. Negative 13.68 plus 57.45. Okay, let's see what we get for this. So the x part is 37.59 plus 48.21. No, 21. 5.8. Okay. And then the y is going to be negative 13.68 plus 50. You know what? I don't even know if my calculator is showing up on the screen right now. If not, I've got a calculator. I'll find out when I upload the video. Okay, so negative 13.68 plus 57.45 got me 43.77. So these are the coordinates of C. I can use this to find both its magnitude and its direction. Let's first find the magnitude. And this is essentially just the distance formula. And since I know that the origin of C is at the origin, this point is 0, 0, this point is 85.8 and 43.7, I essentially, to find the magnitude, just have to do 85.8 squared plus 43.77 squared, the square root of that. And I'm grab that calculator again. There's a couple of calculations I can do in my head, but you know, this is not one of them. 85.8 squared plus 43.77 squared, the square root of that, and I get 96.3. And the original unit I was using, or I was given, was millimeters. So the magnitude of C must be 96.3 millimeters. And if I want to find the direction, I have x and y, and we know that in trigonometry, tangent uses x and y, or actually it's y over x is what it is. So if I want to use the inverse tangent, I'll get the measure in degrees. So I'm going to do that. I'm going to do the inverse tangent of y over x, or in our case, 43.77 over, what was that, 85.8? 85.8. 8. Let's see what I get here. So inverse tangent of 43.77 over 85. No, that's not 85. 85.8. Let's see what direction and angle we get. We get 27 degrees. Or, yeah, 27.0 if we're going to keep it at 3 significant figures. And that looks about right if we look back at our drawing here. When we drew it graphically, we knew that it was a positive angle because it was above the x-axis, and we knew it was definitely less than 50. And if you look at it, you know what? I might not have done my scale too bad here. This looks like it's a little more than the 20 degrees I did here. But either way, now we know the magnitude of C, and we know the direction of C when you add A and B together. And we also know graphically what it's going to look like. I personally find it's easier in certain software and programs that you use online where you're supposed to put in the graphing part. I find it easier to do all the math out first and get these two pieces and then use these to make the graph nice and accurate. So let's say we have this question. Vector A has a magnitude of 45 kilometers per hour in the positive x direction. Vector B has a magnitude of 66 kilometers per hour in a direction that points 75 degrees above the positive x-axis. Let's say we're going to do some subtraction here. First, let me draw my coordinate system here. Again, here's the positive x-axis, here's the positive y-axis. Let's say we want to do some subtraction. Let's say we want to do, I should probably, should I do different colors? You can't answer, can you now? Let's do B minus B minus A equals C. Let's set this up for ourselves. We're going to do B minus A equals C. So I'm going to do the same thing I did for the last one. I'm going to go ahead and draw out what these would look like. Let me start with B. This time B is purple. I thought about using yellow, red, and orange, but I don't think yellow would show up too well. So let's draw vector B first, because that's the first one in the equation here. So vector B has a magnitude of 66 kilometers per hour and points in direction 75 degrees above the positive x-axis. So let's say 75 degrees is this-ish. Again, if I were actually doing this out by hand for like a formal assignment, I would absolutely definitely be using a straight edge and a protractor. But I don't have one for the computer. I probably do, I just don't know how to use it. So this is 75 degrees. 75 degrees and 66. And remember, like last time, we're going to find the components of each of these. Before I do that, let's keep drawing it out. So then A has a magnitude of 45 kilometers per hour in the positive x direction. There's no mention of an angle. So that tells me it is straight along the x-axis in the positive direction. And it has a magnitude of 45. So that's A. I'll be finding those components. And then I'll also be using those, I'll use those to find the components of C. Now, let's see graphically what C would look like. Now, when you're subtracting is the same as adding the opposite, right? So like 5 minus 2 is the same as 5 plus negative 2. So B minus A would be the same as B plus negative A. So let's do that. Let's add a negative A. A negative A would be pointing in the exact opposite direction. It would be the same length. This would still be 45, which would be in the opposite direction. I'm going to do the same process I did for the first one. I'm kind of mirroring this. It's just that I'm using a negative or the opposite of the original A. And so C would have to be, again, start where they both start at the origin. C would be the diagonal between the two. So C is going to be right up here. And so now I know that C is in quadrant 2. That's helpful. But let's go ahead and find what the actual magnitude is. It looks like the magnitude is going to be close to 66, just by eyeballing it here. And let's see, it's in quadrant 2, so it's going to be between 90 and 180 degrees. It's closer to 90, so we have that. We can kind of use that information to check ourselves as we go. So let's go ahead and start finding the components. So x component is going to be x component for b. It's going to be 75 times the cosine. Oops, I'm sorry, that's 66. 66 times the cosine of 75 degrees. It's like 750. And then 66 times the sine of 75. You know, I used to have good handwriting, I think. I think before I became a math tutor, I had good handwriting. I don't know. I don't know what happens. Okay, so 66 cosine 75 degrees. So the x component of b is 17.08. 66 sine 75 is, who would it maybe 63.75. Okay, let's find the components of A. A is actually pretty darn simple because it's at an angle of 0. So the x component would have to be 45 because that's how far it points in the x direction, and it doesn't point up or down, so it's just 0 there for the y. And then if I'm going to find C by doing subtraction, C is going to have to be x, oops, got carried away, 17.08 minus 45 will get me the x1. And then 63.75 minus 0 will get me the y. That one's pretty easy. 75. All right, that one. I'm unwilling to do the other one in my head, so let's do it. Let's do 17.08. Oh, come on. Stop it. You know, I used to work with a math tutor. He was really brilliant, and he never, I think, ever talked to his computer or his calculator and told it not to do things. I wish he had taught me that. Like, how do you not complain and yell at your instruments? Because I don't know how. Okay, so we have the x and y components of C. We can find the magnitude. Why is there purple down here? Let's find the magnitude. Stop it, stop it, stop it. See, someone's got to teach me how to not complain and yell at my computer. Okay, distance formula. So we're going to do the x and y squared, add them, square root them. Okay, second square root. I'm going to leave out the negative here because I know a negative squared is a positive. So 27.92 squared plus 63.75 squared. And our magnitude is 69.595, blah, blah, blah. And my original magnitudes were both to two significant figures. So I'm going to keep this one at 2 as well. And if I do that, I end up with 70 kmh. Whoa. Where did we go? There we are. 70 kilometers per hour. And you know what? We when we visualized it, we said it was going to be pretty close to 66. It looked almost the same length as the purple one. So it's not too bad for rough handing it. Rough, that word? I don't know. But let's go ahead and let's find the angle measure. So we're going to do the inverse tangent. Let's do our y component over our x component. So 63.75 negative 27.92. Let's see what we get. Now, we said earlier it should be between 90 and 180 because of the quadrant it's in, and it should be closer to 90. Let's use that when we get our answer to see if it makes sense or if we have to do tweaking. Negative 27. Shouldn't, but you know. Yeah, negative 66. Negative 66.34. Now that does not match up with what we have here. We know it should be between here and here. So we're going to have to use some of the rules when it comes to trigonometry. And let's see, I'm going to round this to just negative 66. I'll keep it at the two significant figures, like all of them. So let's say we keep this at negative 66 at two sig figs. Now, what we're going to do is we're going to do 180 plus this. Plus this, and we get 113.65, or I guess I should have done 180 plus negative 66, because that's what I said I was going to round it to. So we get 114. So it should be at an angle of 114 degrees in standard position, and that looks about right. It's past 90, but it's definitely well above or far away from 180. So 114 degrees sounds pretty good. So 114 degrees. 14 degrees is where it's at. Equals over there, 114 degrees. But I've been keeping everything at two significant figures, and this is three significant figures. So if I'm going to put this at two significant figures, it's actually going to only be 110, which can seem like it's off pretty far, but we'll keep the significant figures as is. And this here was actually one of the questions from the physics book, from the online physics class. Let's check them here. Oh yeah, by the way, you can use this if you need to double check your answers too. Not too far. All right, so here's the graph. Let's see if their graph looks like our graph. It should. Not as pretty, but whatever. So we've got one going this way, and then these two make a V shape. Very technical terms. Where the heck are you? There we go. We've got one going this way, and then a V shape. Perfect. And then we found the magnitude. We found was 70. And we found the direction was 110 degrees, and that is what we found for both of them. We found our magnitude of 70, and our direction was 110. So whether you are adding or subtracting vectors, I personally find it easiest or best if I visualize it, find the components, use the components to either add or subtract to find the resultant, and then use those components to find both the magnitude and the direction using these steps. That's my personal preferred method. You did see a little peek preview here. There's a vector calculator here. This is another way you can visualize it, and it's going to be much nicer because you're not drawing it by hand or seeing me draw it. This is mathisfun.com. So if you're interested in double checking your work here, or if you ever need graphics for a lab report or something, this can help you generate them instead of doing them by hand or definitely freehanding them. So, but all right, that should be an example of adding vectors and an example of subtracting vectors using the component method.